Welcome back again. This is the second article, and we will talk about the stack of the Bluetooth Low Energy. When we look at the big picture, the entire BLE system is organized into a stack, which is a set of layered components where each layer has a specific job. The higher layer talks to your application, and the lower layers talk to the radio waves. So this is how the stack looks like. We have the application, then the host, which has several sublayers, then we have the HCI, and the controller has two more layers. So let's start by the applications. This is the upper layer. That's the one you will interact with the most. It consists of the software running on the device that actually defines what the device does. So it's kind of bridge between the user and the Bluetooth stack. Then we have the host. The host handles the logic of how devices find each other, connect, and exchange data. And as we mentioned, it contains several important protocols. The first one is the Generic Access Profile, or GAP. GAP is responsible for the device discovery and advertising, and also for connection management. However, more importantly, GAP defines two roles: the peripheral and the central. The peripheral, usually a small low power devices like a heart rate or smartwatch. Its main job is to advertise its presence and wait for the central to connect to it. On the other hand, the central is a more powerful device, could be a laptop, a smartphone, or a tablet. So its main job is to scan for advertising peripheral and initiate the connections. So as you see here, always peripherals advertise, and the central scan and initiate connection. Then we have the Attribute Protocol, ATT. This is the foundation of data exchange. It has also the concept of a server where the device holds the data. Most probably this is a peripheral, but this is from the ATT point of view. And then we have also the client, which is the device need to access to some data. That's most probably again central. And then we have the attribute. This is the basic data unit of data. It's a piece of information, like here, for example, 21 degree, and it has a handle, kind of ID number, and permission, like read only, write. We will talk more about this in coming videos. And then here we have the generic attribute, or the GAT. We will have in the lab a tool where we exactly communicate with this layer. So if ATT defines how to talk, then GAT defines what to say. So GAT gives a structure and meaning to the raw data defined by the ATT. It's organized them actually in kind of hierarchy. So we have the profile, then service, then characteristic, and then the attribute. Just to visualize this hierarchy, this example filing cabinet, for example. So imagine a filing cabinet. A single piece of paper is the attribute. This is the smallest unit of data. And then for the characteristic, this is a single file folder, a single folder. So a folder contains maybe many paper. And then the service is a drawer in this cabinet. So the service is a collection of related characteristics. So service might have more than one characteristic could have more than one attribute. So all this collection at the end form the profile, which is the entire filing cabinet. So this is a little bit kind of visualization, how you can think of the data or the structure of the data inside the GAT layer. At the beginning, let's remember that before client start interacting with the server, the client has no idea, doesn't know what services or what characteristics are available on the server. So the first thing that a client does is what is known as service discovery. Here it's discover okay, what characteristic on the client. Only after that the client is able to communicate with the server. And by the way, all this characteristic, it could be defined by the vendor. So vendors define their own profile for use cases not covered by the SIG defined profile. So not everything is coming from the SIG. Vendors could define their own. Here I provided to you a link to the specification and document. You will see the different profiles defined by the SIG, so you can read here if you are interested. Then we jump to the next layer, the SMP or Security Manager Protocol. I'm sure you are familiar with that. This when pairing and bonding happens. So at this layer, we're generating and exchanging encryption key, the authentication happen, and all the other stuff. The next layer is the L2 CAP, or logical link control and adaptation protocol. So this layer, it just take the data from the upper layer and pass them to the lower layer, or in the other way, it reassemble incoming packets and send them to the upper layer. Then we have the HCI or host controller interface. This is the literal interface. Often it's a hardware protocol, could be a UART or USB, that allow the host to communicate with the controller. Then we jump to the controller, where it has two main layers. The first one is the link layer. Most importantly, here is a Bluetooth device address or BD address. This the address that define the Bluetooth device, and every time when we need to connect to a device, we need to know this this address. It consists of three different LAP, UAP, and NAP here. And also has two different types. The public address, this is a fixed factory programmed address registered with the IEEE. And then you have the random address. This is more common. It doesn't require registration with the IEEE, and it has three different types. The static random, this is fixed until next power cycle. Then you have the private random, and this is resolvable. That's mean when two devices communicate, they share a key. Here it's known the identity resolving key. That's why how the devices can resolve this address. And then you have the private random non-resolvable. I haven't seen this before. So type of address, as you said, public, random. The random could be static and private. The private could be resolvable or non-resolvable. Finally, we have the physical layer, and here we have the 1 megabit per second, we have the 2 megabit per second, and we have also the LE coded. This is a bit slower. You see for S2, the data rate is 500 kilobit per second. However, the range is about 2x the 1M. And the S8 is even slower, actually 128 kilobit per second, but the range is much larger. So this is a breakdown of the Bluetooth low energy stack here. I think now we can start with the lab. So in the next session, we will set up our hands-on lab in order to solve some exercises. So see you in the lab session.